Good evening, everyone. Welcome to the IEEE Richmond Computer Society Speaker Series session, Trillions Spent, Still Failing, Why IT Needs Human-Centered Thinking. My name is Malar Kundappan, and we are delighted to have you with us today. Before we begin, just a few quick housekeeping notes. This session is being recorded, and the recording will be shared with attendees after we have reviewed it to ensure that no proprietary information was accidentally included. We kindly ask you that you do not record this session yourself or take screenshots. If you prefer not to appear in the recording, please keep your camera and microphone turned off. So here's how today's session will run. We'll start with a brief introduction about the topic and followed by the main presentation, which will run for roughly 35 to 40 minutes. And we'll move to Q&A for 10 to 15 minutes. And I also want to say thank you to Mr. Allen for assisting with today's session and helping everything run smoothly. If you experience any technical difficulties at any point, please type a note in the chat and our team will do their best to assist you. The speaker will take questions at the end of the talk, so please drop your questions into the chat as they come to mind. We'll gather them and address as many as possible during the Q&A toward the end of the session. We'll wrap up with about 3 minutes of closing remarks and with a few announcements. Before we dive into content, we want to extend a huge thank you to all our co-hosting organizations. You can see them listed here on the slide. There are around 14 co-hosts who signed up to host this session with us. This event is made possible through the collaboration of all the IEEE Computer Society chapters across multiple sections, our Women in Engineering and Young Professionals Affinity groups, and our academic partners at Virginia State University and Virginia Commonwealth University. Your support in promoting and hosting this event is what makes the cross-section collaboration like this a success. Thank you all for being part of this. With that, let's turn to why we are all here today and why this topic matters so much to anyone working with complex systems. When a major IT systems fail, it rarely comes out of nowhere. There are warning signs, blind spots, and decisions that quietly stack up over months or even years. The real question isn't how did this happen, but why didn't we see it coming? That's exactly what we are here to explore tonight. How to recognize, manage, and prevent technology failures in complex environments by putting real people at the heart of a design and decision-making. Our speaker is uniquely qualified to lead this conversation. He has spent more than 5 decades analyzing, designing, and managing complex IT systems for Fortune 100 companies, government agencies, and global consortiums, helping them understand why systems fail and, more importantly, how to prevent it. He has served on high-stakes panels, including the post-Challenger NASA Software Safety Review, and is a widely respected author and a longtime IEEE Spectrum contributing editor, known for his insights into recurring IT failures and the organizational patterns that make them more likely. If you would like to explore his work further, please simply Google his name and you will find a wealth of his articles, talks, and interviews. It's truly my privilege to introduce our distinguished speaker for this session. Please join me in warmly welcoming Mr. Robert Charette. You can start sharing the screen, Mr. Robert.
Okay. Let us hit that. All right. So I'm going to present now. Let me get the right window. And is anything showing up?
It is.
Yes.
Okay, so let me actually get to another panel here that I can actually click on. Thank you. I love technology. Good evening. Thank you, Malar and Alan and the Richmond IEEE Computer Society for inviting me to speak tonight. I'm going to talk about a series of articles that I've written for IEEE Spectrum over the past 20 years, starting with Why Software Fails in 2005, which you can find pretty easily on the web, and ending with the article I wrote last December, that came out last December, which was called, Trillions Spent, Big Projects Still Failing, as well as some of the other articles I've written for IEEE magazines, Computer, IT Professional, IT Software. I've added at the end of the presentation, so when you get it, you'll see a whole reading list, and you'll also see in the presentation I've embedded some links to different articles that I've written, and to news stories that will help you link to what I'm talking about at any particular point in time. One of the things that I've tried to do over the years is to look at how the human aspect of project failure has been overlooked and how it's really a center for success. So this is the theme I'm going to really concentrate on tonight. And we talked about having a question and answer period. I will hang around for some period after 9 o'clock to answer any other questions that we can't get to. I can't, we're not going to spend all night, but I'm willing to hang around for a little bit if we get a good conversation going. So first of all, what's human-centric computing? This is from a article back in 2000, or actually a special issue in Computer in 2007 that has a whole series of articles, one of the earliest special issues on human-centric computing. And basically what the focus was back then was on creating IT systems that are intuitive, accessible, and improve the way people interact with technology. And that's a very important point. And part of that thrust was in the early 2000s was the problems that people are having interacting with the computer. I want to expand, and this is starting to expand in the AI community, about human-centric computing involving everyone in the process, everyone in the enterprise, because you can't really talk about IT anymore as being the sole domain of the developers, and then we have users. It's actually the whole enterprise is what we need to think about, and we're not going to have success in large complex systems unless we take an enterprise view. So if we take a look at the interactions with technology, the two cover pages from Spectrum, one last December, the Hyundai totally automated factory for their vehicles that they're putting out now. It's a very small number of people. And then a cover story that I wrote about legacy systems from a few years ago, I think it was 2020, that looked at the continual failure of legacy systems and how that is impeding what the benefits are of automation. Now, what's interesting about this is, on one hand, the automated factory is there's the sub issue in terms of AI and automation and getting rid of people. So that's another aspect of human-centric computing that we need to worry about. And on the legacy side is, again, what happens, how we have trillions and trillions of dollars. No one knows how much we actually have in the US alone in terms of IT, hardware and software, and training and all the other bits that we add up into the cost of IT that actually are legacy. But we do know that the vast majority of money that's spent in IT, of the billions that are spent every year, actually the trillions that are spent every year, is in the legacy side of the house. So we have this kind of duality that we need to worry about from a human-centric point of view. And in fact, we have this paradox of kind of this persistent failure in the face of success. We have this great success in automated factories. Think about how much software is actually in there. And then also think about how much software we have existing that we're trying to maintain. So we have these success stories, but at the same time, we have these failure stories at the same time. What's our stake in all this? Why do we even care? Well, if you take a look, every major social policy in the US and globally now depends on correct, reliable, and affordable IT at its core. I'm going to ask you a question just to think about. Imagine if you did not have computing, right? Go back to, say, the 1940 era, And how would you implement today's social policy without automation? I ask you, how would you actually think about doing that? That's a good, gazunking thought question, because it would be impossible, I believe, to do almost any of the social policy that we're trying to do. We might still be able to do Social Security, but we'd have armies of people doing that with paper files and mail. So one of the things that has changed the stakes a lot in the life that I've been in, working in computing since the early 1970s, is that everything is now linked. And now what we have in terms of our stake, we have things with electronic health records, with renewable energy, with robotics, drones, AI, giant data centers, quantum computing, and again, legacy is this thing of the digital public infrastructure where things now are all being connected and in fact are being depended upon. So, I'm not sure if you had to have gone to Social Security like I have, or dealing with the IRS. If you're going to deal with those, you now have to use something like government login dot something another, or ID Me, which is another example, which is a private enterprise that the government has used to identify you to actually be able to use their sites or gain their benefits. So the IRS, Social Security, VA, DHS, Department of Energy, 27 state unemployment offices all use these other aspects that are not under their control, where before government would build all the infrastructure and control it. Now we're outsourcing this, and we're using things like AWS or Azure. In fact, what we have now is we actually had just a Azure outage. Microsoft's cloud system was out yesterday for 10 hours, affected a number of systems worldwide, including government services. So now we have government and private enterprise is now all interconnected. So if we don't get this right, and this continues, this isn't going to go away. It's going to be even more closely coupled. We're going to have big problems if we're not really careful. In fact, my claim is, next to the electrical infrastructure, with IT is merging into it in what I'd call an obligatory dependence relationship. You can't use one without the other. A failure in computing now is a failure of the social infrastructure, the system infrastructure, and it's a threat to modern society. I don't think that we're on a thin edge of the wedge if something really does go wrong, where there's predictions now that we may have weeks or month-long data center outages. And can you imagine if those data center outages are connected to government systems, are dependent on those systems? So again, we got to do this right. What's interesting to me about IT, and something that I've written about quite a bit over the years, is this kind of paradoxical tension and dilemmas in IT. For instance, it's ubiquitous, it's everywhere, but it's incredibly fragile at the same time. A single line of code can take down a whole system, and can take down system of systems depending on what happens. Again, we've seen this where somebody makes a DNS change that didn't go right, and all of a sudden a whole series of websites, tens of thousands in some cases, have gone offline, or a software update that's gone wrong. We have exponential capability. I mean, take a look at where computing has gone just in the last 5 years, but we take a look at what we actually understand about it. There's kind of this linear learning, but at the same time, exponential capability that's been created. We have automation at scale, but we have error at scale, in terms of just normal error, or things that have to do with cybersecurity, or a hardware error that can massively take things out as well. We have rapid innovation, but we have institutional amnesia. We do not learn very much about our failures and what we do. We keep thinking that everything we do is new, and what we've done in the past doesn't really apply. We have data abundance, but we have insight scarcity. We don't really have a good clue on how all this stuff really interconnects and what this data actually means that we're all collecting. We have automated control versus human backup, which means that when the automated control goes south, the humans have to jump in. We'll talk a little bit more about this automation paradox, as it's called, a little later in the presentation. We have global dependence and local understanding. Again, this issue that no one really understands how anything works on any scale in IT anymore. It was hard even when I was in school back in the very early 70s, understanding how small systems work. Now we're talking about systems to systems, or IoT systems that no one understands those interfaces or how they interact with one another. We've been actually pretty damn lucky that we haven't had a massive global outage that has lasted for weeks. What's interesting too is that this is information from a great series of papers and studies by Bent Flyberg and Dan Gardner. Bent is a professor at INSEAD at Oxford. Dan Gardner was a PhD student of his, came from McKinsey's, and brought a tremendous amount of data that they were able to analyze on IT projects. And what was interesting about their data analysis is that they had what was predicted and what was the result. So they could really do some great comparisons and some great statistical analysis. And what they've been able to show is that IT projects are 20 times more likely to fail in comparison to other types of projects. Think about that, 20 times. And they are the riskiest of all projects in terms of cost. You know, we all know about cost of failure in IT. And if we take a look, these are numbers that have come out of some studies that Herb Krasner has done at CISQ. In terms of these costs, the operational costs per year is he estimates about 1.8 trillion. Software development costs that are cost of failure is about 260 billion. And then what I call opportunity costs, or people call technical debt, or I call mission debt as well, is about $2 trillion a year. These are phenomenal amounts of money. And even if these are exaggerated by, say, 50%, they're still phenomenal amounts of money when you do it on an annual basis. I want to make the point too, and this is again a theme of the talk, that risk is not a technical property alone. It is a property of the system, and that includes humans in that system loop. I'm going to talk about two projects in a little bit of detail. I'm not going to spend a lot of time because I've written about them. You can read them about them in the article I wrote in December's Spectrum, as well as some other links that I've had in here about the Phoenix Pay System up in Canada. This is a poster that the Public Services Alliances of Canada, the Public Service Union there, put out 2 years ago. I love it because it's a great graphic, and I updated it as it's the 10th unhappy anniversary on the 24th of this month, and they have this idea that they've all been burned by Phoenix, which is a clever marketing and public relations element. This is their latest one, where does this mean 6 more years of Phoenix pay disaster? Because it's going to take probably 6 more years before they get a new system up and running. Now, Phoenix was kind of an interesting pay system. What it meant to do was replace a 4-decade-old regional pay system with some customized PeopleSoft payroll package. The project began in 2009 and was planned to be rolled out actually originally in 2014, and it slipped to 2015, and then it was 2016. Now, what's interesting about this is that 4-decade-old regional pay system should have only been a 2-decade-old pay system, because they tried before to build a payroll system, and that fell flat back in 1994. What's interesting about this is that they had a few kind of interesting requirements. These are two of the big ones I'd like to point out. One, they had 80,000. Think about it, 80,000 pay rules spanning 105 collective agreements with federal public service unions. And one of the things you have to remember is that those public service union agreements were also being constantly negotiated and renegotiated. So as you're trying to build a system, it's changing. Those pay rules are changing, right, at the same time. They also had to create 34 human resource system interfaces across 101 government agencies. Just think about how many people you need to talk to figure out what those interfaces are. And then you have to ask, who owns the interface? Does Phoenix own the interface, or do the government agencies own the interface? Because this is the private information that's passing back and forth between the Phoenix automated system and these government agencies, who all have, again, different public service union agreements, as well as the Canadian agreements as well. So add to this is that the estimated cost was $310 million. They've currently spent 5.1 billion Canadian dollars trying to fix this thing. And what was interesting, and we'll talk about it in one more slide, is that a lot of that estimated cost was actually unestimated by about 40% at the beginning. So think about that. That 310 million really should have been closer to 450 million as their original estimate. But over 70% of the 460,000 government employees have had experienced, been underpaid, overpaid, not paid at all. Most of those people, of the 70%, have had multiple pay issues. So think about it. Every 2 weeks, you get a pay slip and you wonder whether or not it's screwed up. And if it is screwed up, it's going to take a long time to get fixed. The Auditor General, who sadly passed away a few years ago, wrote a number of audit reports. I've buried one of them in the notes, where he calls this an incomprehensible failure of project management and oversight, which was kind of an understatement, to be honest. Because if you take a look at the case study, at what was happening, the very first thing was that politics overrode any engineering sense. They knew they needed a new pay system, but they weren't going to actually do the things that they needed to do to make it work. They underestimated the complexity and the cost. I told you, underestimated the cost. IBM, who was the contractor, came in with a bid and they cut it by 40%. Okay, now by cutting by 40%, they decided, how are we going to do this? Well, what we're going to do is we're going to sacrifice functionality, we're going to sacrifice testing, our support, our training, all within to keep within budget, but also to make this political promise of how much they were going to save by using this new pay system. So all of a sudden now you have another set of dynamics that come in. They were supposed to have a number of pilot rollouts. They scrapped those, and they decided to run in as well as parallel. The idea was to run the old pay system while you brought the new one online, right? The old, don't ever do a big bang pay system. They said, now we're going to do a big bang pay system. So even when the first rollout, they rolled it out in 2 phases, was having troubles, they said, too late, we already closed the old one, so we can't go back. So it was we're going forward regardless. So they ignored the warnings. They were the risk signals were out the kazoo. People who they brought in from the government agencies to help them with the pay system and told them that things were going wrong. They just ignored them. And I mean, the details, I could spend 2 hours just talking about this, but I won't. You can read all about the nastiness about what happened. But one of the questions is where are the human-centric concerns in this? Think about it. Which one of these says we're worried about the people who are actually going to get the pay, right? Where is this? When you cut the budget by 40%, does that say I'm worried about what's going to occur because I just took this huge risk? And who's going to suffer? The people who get paychecks, right? The other thing is consider the ethical dilemmas of the software engineers on this project, right? They know. You can't tell me that those people did not know that this was going to cause massive problems. And what do? Do you walk away? Well, that's pretty hard. A lot of junior people working on these projects aren't going to say, I can walk away. I'm independently wealthy. I don't need to work for this company. I work for somebody else. And if it isn't you, they're going to find somebody else. So again, this is something that is not talked about a lot when we talk about project failure, about all these other things that are going on. Just as an update, as of 31st December, just 5 weeks ago, they still had 45,000 pay issues that they were trying to. This is part of their backlog that they were trying to deal with less than a year old. But they still had 111,000 pay issues that were more than a year old. Some going back 3 and 4 years, some even older. And they have over 75% of the checks have to be manually processed. They have to be checked manually because their automated system doesn't work, right? So they've spent $5.1 billion for a manual system. Think about that. That just blows my mind. I cannot believe that they actually, if I was them, I would never publish an audit report again about any IT system. It's just, it makes me laugh. It actually makes me cry too much. But anyway, so here's another one. Horizon Post Office. This is even worse than the Phoenix Pay system. Here you have an electronic point of sale system that the UK Post Office wanted to bring. They were trying to automate all the postmasters. I'm not sure if you know what happens at a post office in the UK, but it's kind of like a store where you not only do postage, but you can get checks. One of the things too is that they wanted to have the original point. The original system that they used was actually built by the Department of Social Security and the post office to be a smart card. And the smart card system didn't work. So they decided to use part of the technology and put it into an point of sale system. One of the reasons that DSS walked away, I had worked at DSS for a number of years in the UK before this, but I'd worked for them from '86 to about '93, is that DSS walked away from this because it didn't work. So they took a technology that didn't work, decided to revamp it and put it in as a point of sale system. So it wasn't even purpose built for this element. They rolled it out in 1999, and it had hundreds of errors, hundreds of bugs that were deliberately hidden from the postmasters. They were told that here's your automated system. It works really, really well. But the postmasters were complaining that there was problems with trying to balance their books, because they had to balance each, their tills every evening, and there were shortfalls. And if there were shortfalls, they were responsible for it. They were actually the ones who had to make up the differences. So they were complaining that there was a problem with the Horizon system, but the post office insisted that it was fundamentally sound and robust, even though they knew there were bugs in the system. In the UK, it's similar to the US, but the UK is even a little bit stricter. There's this presumption that if your computer system is up and running, it is material, it is reliable, it is accurate, unless you have data contrary to it. Now think about it. This is a catch-22. How do you get data that's contrary to this? How do you actually get in there if you're just a user? You're a postmaster and there's something wrong. You have the code, you don't have access to the code, you don't have any of this. So you have to try to hire somebody, and the post office doesn't have to give it to you. So what you have here is a system where the post office dishonestly accused 3,500 local post managers of false accounting, fraud, and theft. 900 were convicted, and over 200 were jailed based on buggy software that wasn't found to be buggy until the deception was broken over. There was a famous court cases where the judge basically looked at the evidence and said, this is all bogus. You convicted these people wrongly. And it's actually turned out that it's all over the UK news. There's lots of news stories. Computer Weekly in the UK has hundreds of stories about this going back to like 2009, 2010, called the greatest miscarriage of justice in British history. I call it administrative evil. This is something that the organization sent people to prison on buggy IT that they knew was buggy. And they refused, the lawyers who were defending these people, they refused to let them know that that information was actually available and that it was buggy. If that information had come out originally in 1999, none of these people would have gone to jail, because the system probably would have been shut down. Again, where are the human-centric concerns? You can't find any in this. Okay, it's phenomenal. And again, I don't even want to bring up the ethics issue, but again, think about the people who worked it was that Fujitsu was the vendor who were working on this. And what blows my mind, to be honest, is there were no whistleblowers coming out and talking about this. That's a whole nother subject that we could talk about. So again, crunch numbers, not people. This is just, I'm not going to go through this because I don't want to spend the time. The idea is here is that these two systems are just one of a bunch, right? We have, and I have links to all these that we can talk about. You know, the CrowdStrike, just a software update error, you know, bringing down, you know, thousands of websites. Land Rover having a cyber ransomware attack that stopped production for months. You have things like Social Security Disability Processing System, where they found that for 5 years they were 24 to 36 months away from the first release. Think about that. For 5 years they were able to keep saying, well, we'll be there 2 years or 3 years from now. No governance. This is again, where's the human-centric element of it, and all the people who are working on these systems, that just has to be some of these most terrible working conditions. What's even worse, I'm going to shift gears just slightly, is that we've now moved again to the algorithmic basis for these systems. These are just 3 of several hundred. There's actually groups now are tracking AI errors that are occurring in systems. The Michigan Midas unemployment system. Here's a system that they decided to update their unemployment system. They're going to turn it over to an algorithm who is going to look for fraud, waste, and abuse, people claiming unemployment who shouldn't do it. They accused over 40,000 people were falsely accused. Part of the assumption set that Michigan used was that if you applied for unemployment, you were basically fraudulent from the beginning, and you had to, in essence, prove that you weren't fraudulently looking for unemployment. It was the same thing in Australia's Centrelink system, which was a welfare benefit system. They accused 400,000 people, falsely accused. The Dutch child benefit system, 26,000 families were falsely accused, and numerous hundreds of children were put in foster homes because their parents were accused of fraud, which they weren't guilty of. So these had superhuman impacts that, again, you don't read about very much in the mainstream news at all. But these are things that are happening every single day. And what happened in each of these cases, there was no human oversight of the algorithmic decisions. And in fact, in the Midas case, the government officials there in the unemployment office thought that this was a great thing, that they didn't have to have human oversight, because so many people were being accused of in their mind, not falsely accused, were being accused that it was working really well. And the same thing in Centrelink. The number of falsely accused was used as a criteria to say that this is a working system. And it wasn't, I mean, you had to drag people for years to figure out what actually happened. The government fought tooth and nail to stop any type of looking into this. And again, where are the human-centric concerns here? Where? Now, this is what I was talking about very in the first slide or second slide, is about the ironies and paradoxes of automation. This is a very famous paper by Lisa Bainbridge back in 1973, where she identified kind of this paradox about computing, is that the more we have automated systems, the more crucial the flawless, I added that, the flawless contribution of the human operator becomes to the operational success. The paradox is that the more reliable the automation, the less the human operator can actually contribute to success. So like, if you take a look up in the left-hand corner, that's wreckage from Air France Flight 447, the crash in 2009, where they had frozen pitot tubes, which basically told them it's speed sensors. The aircraft went off automated pilot. The pilots had absolutely no idea what was going on, because the computer basically said, I don't know what's going on, so I'm turning it over to you. pilots. Well, the pilots didn't have any understanding of why the computer decided to turn it over to them. And what happened is that they crashed a perfectly flyable airplane and killed hundreds of people because of that interface not being thought through. And it's happening more. It's happened in numerous times. There's a Turkish crash in the Netherlands. There's the crash of the 737s at Boeing. There's ships running aground. DC Metro still has problems with their safety and their automated systems. You have Waymo. I mean, the more we get into automation and the more control we have, the more this automation paradox comes in. Anybody who owns a Tesla, that's, an issue that you have to worry about. I see somebody coming up with a little chat there. Yeah, that's absolutely true. Tesla has made you the person who now has to figure out why that Tesla is turning it over to you when it gets off its automated driving FSD. Now, I don't want to, people hate inviting me to parties because I always sound so negative. But, software engineering has made a lot of progress. Okay. Things are much better. I mean, the reliability of systems, back in the 70s, 80s, 90s, even 10 years ago or 5 years ago, things are better. We have, things have gotten better. We have better code. Okay. And AI is probably going to improve a lot of these areas. We are going to have better code through AI because we're able to eliminate a lot of the silly mistakes that humans make, especially in terms of understanding the rules of what a particular instruction means. My work when I was an undergrad and grad student was in architectural design and instruction set design. And again, AI is much better at interpreting what that means versus a human. But at the same time, software engineering still has to deal with all these different pressures, traditional versus modern development. I don't know how many people, maybe people want to raise their hand or something, or send a little emoji or something in terms of how many people are still having agile versus DevOps versus, some other type of development war in their organization. I mean, it's constant. You can read this in Reddit. I mean, I don't even want to go there anymore. We have naive assumptions and constraints, some of those that I've already talked about in Phoenix and in Horizon. We have persistent technological or technical optimism and bias. We really are looking at IT to save our butts. And we believe that we can do it, especially those who are politicians. Very easy to pass a social policy and say, well, we'll let the programmers figure out how to actually implement it. It ain't that easy. We have incentive misalignments, which I'll talk a little bit at the end. We have system of systems interactions. That's been the big area. And one of the areas that we really do not have the skills in is systems of systems engineering. That is a real black hole that takes a long time to develop, but we're not developing it in universities and we're not developing it in practice. And that's gonna bite us pretty hard, I think, in a number of areas in the next few years. As I said, we have IT failure amnesia, and there is this unwavering belief that IT is the universal hammer. It can fix everything. And in fact, you can see a lot of social activists who believe that IT can solve every single social problem in the world. Good luck. So software engineering isn't going to be enough. Here's a great article. This is from my friend Steve Andurel. He's a professor. He's written an article. This is in Forbes magazine. Again, you can get it online. He talks into the fishbone diagram of different things of why we have technological project failures. And he's kind of divided it into two different groups. The top group are kind of what are things that are within kind of the software engineering community domain, definition problems, scope problem, management problems. The bottom ones are what are kind of organizational, talent problems, support problems, cultural problems. He says that if you are trying to build a system, if you can deal with what I call the systematic problems, you have a fair chance, as long as the bottom works. If you have systemic problems, even though you don't have systematic problems, you're doomed. He said, don't even try to create an IT project if you have any of these systemic issues. And he has a lot of data to back that up. So if we switch this around a little bit, I've restacked things now. We'll talk about an organization. I've just put in kind of 5 layers, actually 4 layers and an external layer. Up at the top, we have the C-suite, the executive suite. There's this political intent, this narrative. We will fix something with IT. We're going to modernize our payroll system. Okay, so you have to have some policy and program design. So there's budgets, schedules, laws, mandates that you have to worry about when you're building these systems. You have your system architecture, which actually starts to encode your decisions that you've made. And in a lot of places, because you have so much legacy systems, your legacy systems code what you can or can't do. You have development, tests, and operations, all the things that we in the IT field deal with. And then hopefully, by doing all these things right, we can have some positive human consequences. The system works, it's reliable, it's accurate. But we need to worry about, if we're going to do this, both those systematic as well as systemic issues. And what I mean by that is that we need to worry about these things together, but also across organizations. If you work on large IT projects, they are not done just internally by one organization. You have multiple organizations. You have to worry about multiple organizations and what's going on with them, because every one of these things, every one of these organizations have different ways of doing things, different organizational cultures, different ways of communicating, and how they decide to have, where they're going to spend their money and where they're not. So if we take a look, I've written a lot about this. I'm not going to detail about the 3 root causes of risk being the lack of information, lack of control, and lack of time. What that means, the lack of information is pretty obvious. You have incomplete information. Control loss, again, who makes the decisions, where's the decision ambiguity, time compression, scheduled, things like that, things that have to do with time. And so what we find is that if we start up at the top and we start to have lack of information or lack of control or lack of time, and we'll show why some of these occur, these things are going to flow down. So at the bottom, the development and operations, the IT staff is the one who is sitting at the bottom. We know what happens, what rolls downhill. And so our positive human consequences are very dependent on what's going on above each one of these layers. Now, I'm showing it just top down, but we know, in actuality, it goes sideways, it goes crossways. It's a mess. If I were to show that, there wouldn't be anything other than a million arrows going in different directions. We now also have to worry, when we're actually looking at this, about what I call wildcard externalities and internal spillovers, academic word for all these internal programs. So I'm just going to kind of go through this quickly. Up at the top, right, we have these externalities. We have to worry about what's happening in the economy. We have to worry about what's happening in competition. We have, what's our strategy? Are we a growth strategy, a profit strategy? Are we trying to be stable? Are we into cost cutting? What about government regulations that are coming in and affecting our company? Right, when Starbucks hit back, when the Enron thing hit, and all of a sudden, all the way that we did cost accounting had to change, and accountability had to change. At the policy program level, we had all these different initiatives. I can call them FAD. TQM, management, by walking around, IPTs, business process reengineering, balanced scorecard, all these things change how decisions are made and how processes are going to be done down the level. System architecture, we have all sorts of different types of system architecture. Lots of companies have all of these at the same time. You have ERP systems, you have the cloud, you have your web service, you have client server, you have software as a service, and then you have, at the development level, how many different things have occurred. I started out where, I hate to admit this, but our big debate back in the early 70s is that, was GoTo dead? Okay. Does anybody even know what I'm talking about? So all these things are occurring at once that actually, make it very difficult to actually manage a system and think through a system development. And you also have to remember that when you're dealing, as I said, with other organizations, they're going through these things too. All right. in a one government organization, the DoD for a long time said on government projects you had to have integrated product teams. And I was on an analysis team that we looked at 50 of the largest software-driven IT programs in defense. And one of the comments was that IPTs was a great way for taking a long time to make a bad decision. So these are types of things that you have to really worry about when you're actually doing this out in the field. So we have these mismatches, right? These human mismatches. We have all these things that are happening within the organization, all these activities, and they're flowing down and flowing up and flowing across other organizations. I'm going to do a kind of a simple chart. These things actually, if you don't worry about the human system aspect, create what I call these vicious cycles. Okay, so if you start at the top, say you have no system vision. Okay, let's go to Horizon, for instance, or something where there's another one, the Expeditionary Combat Support System for the Air Force, which was either, depending on what you read, either was trying to integrate 780, 240, 77, or 360 different systems into one. They had actually no idea what they were trying to do. If you have no system vision, what's the consequence of that? Well, now you have conflicting priorities because nobody can tell you what you're trying to do. Those are kind of systemic and systematic, right? No system vision, that's a systemic thing. That comes up at the top, okay? We're going to fix this with IT, or we're going to use IT to move forward, okay? Now we can go around, and again, I should add a point here. I added this in because I was going to forget it, is that what's the cost of fixing things downstream? Right, we know in the IT community, there's this kind of rule of thumb, right? 100 to 1, right? If you don't fix it in requirements, it's going to cost you 100 times to fix it in test, right? Well, what about if the vision is gone, right? If there's no vision at the organizational level and that flows all the way down, is it 100 to 1, 1,000 to 1? Like in Phoenix, it's what? I don't know. I can't do the math in my head that quickly, but it's large. It's a large number. So if we keep going around, right, we have poor project oversight. No system vision is going to lead to poor project oversight because we don't know what it is that we're trying to build. That gives us missing activities later on because we're not defining what they are. We have poor resource management because we had poor project oversight. We don't know what we need. And what did that do? We take risky shortcuts to try to get back on schedule. There's a very simple vicious cycle. When you actually do these in practice, you have dozens of these interacting with one another. But you get the picture. You have systemic tensions that you need to worry about. And if you have these, it becomes a difficult thing to unravel. So again, back to my basic question, where are the human-centric concerns? So if we're going to reduce these mismatches, we need to start thinking about how do we create a virtuous cycle? How do, instead of going into a doom loop, we can get out of a doom loop? Well, really good organizations, again, have a defined system vision, which then gives you the ability to have priorities understood. You have strong governance, which allows you to have task alignment. You have resource managed, which allows you to have processes followed. Now, is this perfect? No. But the issue here is that you don't have human-centric in the concerns at all in the vicious cycle, but to achieve the virtuous cycle, you have to have human-centric concerns at the very forefront. If you don't, you can't get there. It goes back to what Steve said about if you don't have those systemic elements nailed down, you can't get there from here. You're not going to be able to be successful in your project, at least not without a tremendous amount of more money than what you thought you were going to spend up front. Now, backing up a little bit, this is a great book. If you haven't, he's a civil engineer, Samuel Floman. He passed away a few years ago in his 90s. I think he was 92 or maybe even older. Wrote a whole series of good books. If you're an engineer, you really need to read his books. In this one, he talked about every mature engineering field has three things that you can show. They understand that early decisions dominate the outcome, right at the very top, just as I showed in that previous slide, at the very top. Uncertainty must be surfaced, not suppressed, which means you have risk assessments and you don't call risk challenges. You don't call them, something else, or you just, suppress them totally. and that systems are going to fail in ways that designers didn't imagine. So you need to have resilience. You need to figure this out. The IT industry is a long way from this, unfortunately. I've been talking about this for a long time. People have been talking about this for a long time after I'm long gone. This is from the Challenger report. Dr. Richard Feynman, professor at Caltech, physicist, he talked about this whole aspect of what happened with the Challenger, but you see this in IT projects all the time. He said that for a successful technology, reality must take precedence over public relations, for nature can't be fooled. And that's what we tend to do in our IT industry. We tend to fool ourselves a little bit too much. Just kind of, in some sense, summarizing, we start at the end users, right? They're the ones who are going to bear the consequences. We never talk about end users, right? When we talk about project failures, typically in the literature, we say, oh, project failure costs $3 billion. Well, that was the cost of the organization. We didn't talk about the $10 billion in opportunity costs or other things that occurred to the end users. It's like when an airline says, well, we have a reservation problem, we have to cancel all these flights, right? Well, they add up the cost that they've lost in ticket sales. They don't add up the cost of what it was to the flyer. Similarly, at the developers, we have real problems at the developers. We ask a lot of developers. We ask a lot from our IT folks. We don't give them the resources. We don't give them the tools. We don't help them learn about the biases that these tools have. For instance, most of you have probably used some type of reductionist approach to design your systems, basically a tree-like structure. Well, tree-like structures, there's a human bias that if you use tree-like structures, you tend to underestimate the cross error rates that go from one tree structure to the other, because you look at them as trees. You don't think about the holistic error that flows across trees rather than jump up and down. The same things when you do cost estimates. How do we do cost estimates? Well, we teach people to do cost estimates. Well, you break it down. You have requirements, you have design, you have this, and you put costs for each one of those. There's a human bias. It's called conjunctive bias, which says that if you break things down in a stepwise fashion, you are always overly optimistic. So we build tools that make us underestimate the error of our designs and underestimate the cost of those designs because of what we put in our costs and schedules. And then up at the top level, again, the ROI, we don't include what happens at the end users. So we have to account for the risk beyond traditional measures. We need to worry about frameworks that help the developers think about human considerations. And again, end users cannot be an afterthought. I'm almost done. And so you have to ask, what must be done here to reduce the impacts there? Well, some simple design heuristics. You have to redefine the system boundaries. You have to take a very holistic view. I picked this from Da Vinci on purpose because, again, this is the whole view, the earth and the sky together. So you need to have your end system view has to include everything from the whole organization has to be involved in getting there to success. You have to keep humans meaningfully engaged. You can't, one of the things when I developed lean software development in the early 1990s was that one of the rules was that the customer had to be engaged. If we did not have customers working on the project, we didn't do lean development because it wasn't going to work. You have to design for the risk ecology. It's a term I've come up with. I call myself a risk ecologist. It's what it means is that you worry about finance, social, politics, technology, the economy, all these different things, all these different elements that come into real projects. They're not these clean little things of saying, oh, I have a requirements problem, or I have a scope problem, I have the. Those are just symptoms of something that's much deeper in that organization.
You want me to do that again?
You need to also ask where the error goes. Now, this might sound a little confusing, but I'm going to give you a simple example. Go back to when we talked about like the Midas system or the Centerlink system. These systems, algorithmic based, they have false positives. How big should those false positives be? What's the error? How do we place that error? what should we determine that error to be? Okay, because that's something about, we have to ask another question: who absorbs the error when the model is wrong? Okay, that's a human aspect. We have to make AI errors discoverable and visible. Those are things that are happening now in Europe. There's laws that are starting to force that to occur, but the AI companies are totally against it. They do not want to let anybody know how they're actually deciding, when you're working with a chatbot, how it came up with those answers. And we also need to have professional ethical accountability. You know, if we don't have that, it all this is for naught. Two questions I always ask when I used to ask, because I'm now retired, is you have to ask, what do I know about the system I'm trying to build? And you have to ask the other aspect, what do I need to know? Those are two, that's a very powerful set of questions. I'd really, you know, if you're working on projects, try to think about that. Almost done. We know how to build these systems. There are case studies, there are companies who have built these systems. They're just a very small minority. But we're fighting 75 years of what know-how beating know-what. This goes back to Norbert Wiener, the father of cybernetics, who he talked about, we're getting ahead of ourselves. We're building these systems where we don't understand what the implications of these systems are. So we need to understand on that. We also have massive financial incentives for building crap software. I mean, it's a well-known, you know, it's a heuristic in computing. You never get enough money to build the system right, but you can get an infinite amount of money to fix it. So the incentives for building it right is, just from a revenue standpoint, isn't nearly as much as from getting paid to fix it. We really are addicted to failure porn and puffery. What this means is, failure porn is that, oh, you become successful by failing. Well, if we have failed so much in IT that we should have perfect systems every single time. Actually, one of the questions I have is, how many ERP systems do you need to build? We've built hundreds, if not thousands, of these big systems, and yet the failure rate is still close to 70 to 80% for these systems. How many of these do we need? Have we not failed enough? Do we need another 100, 200, 300 failures? We're going to figure it out. So I'm tired of people saying we're going to fail our way to success. That's crap. Okay. We also have pompous puffery, or, you know, vaporware. I mean, this is just another issue that I have a hobby horse on. I've written papers on this, is that vendors lie. If you do not get it in the contract, then you don't have anything. So don't believe anything, put it in the contract. If they say that we're going to use top line people, put it in the contract. You'll find out that they don't want to do that. It's a lot better to have junior people work on these big projects. Lack of accountability lead to poor decisions. We really are poor in holding anybody accountable to these systems. The folks who were accountable for Phoenix got promoted upwards and are now managing other projects. And who knows how they're coming out. Again, another hobby horse. We don't learn. And probably the thing that bothers me the most, this collective societal shrug of shoulders. We accept IT failures as if it's just normal. We have to stop doing that. This is especially the IT people. You need to stop accepting all the crap that's being loaded on you about building these crappy systems with too little money, poor tools, flawed schedules. You know, I'll still come in, I'll do it for free. If you think you have a system that's really screwed up, you need somebody to come in, I'll come in and take a look, and I'll tell your CEOs that they're all screwed up. So who's going to change the behaviors? I'm retired. I've done this for 50 years. I'm done. I'm going out and photographing birds and animals and other things. So who's going to do it? It's you guys. Okay. This is a picture from the Rising Stars Conference, the IEEE Rising Stars Conference in Las Vegas. It's held every year. It's over to you folks. You folks are now the people who have to solve this. I'm done. I got a lot of stuff that I've written, but it's up to you. I know I've gone over. I apologize for that, but I can take some questions. Again, I've added a reading list in this, so I think that's it. Now I just have to figure out how to turn it over back to stop sharing. So there it is. Sorry for going over, but you were warned.
That's a great session. Thank you so much. I haven't seen any questions here, but I would just like to.
Questions, by the way. Sorry to interrupt. To talk over you.
No, please go ahead.
If anybody wants to send me questions, send them to my email. I'll be more than happy to talk. Or if you want to have a talk, send me a link. I'll be more than happy to chat. You know, I've been around this field for a long time. People know that I'm a gadfly. I take no prisoners. Yeah, I've worked on a lot of super big projects. I know where all the bodies lie, and so I can help you with advice, whatever. I don't, I'm out of the business. So this is just fun for me.
So this is really great. I see there are some hands I have, but I was wondering, like, what is the questions that we should ask ourselves? And you said, like, what do I know and what do I need to know? So if those are all the questions that we have to put through to make sure, like, we are not repeating the same mistakes or stop from being next cautionary tale, right? But I will leave everyone to have their questions asked. But there's one question that keeps coming to my mind when you were saying, we have been seeing a lot of articles and you presented so many insights into the different occurrences. But what is that one single stubborn mistakes that we keep repeating, or the patterns that the organization's repeating that we are still not able to come out of it? Like, how would we break those patterns?
Oh, God, that's a really good question. It's a really hard one because it comes down to finance. Okay, everything is follow the money, right? It's this issue that ever since I came into the business, I wrote my very first program in 1971, and I wrote it for a Cyber 70 system. It was a big mainframe that CDC put out. Doesn't exist anymore, but it was a big kind of like a Multics program. But even back then, it was always about how do we do things faster, cheaper, better. And IT has always been driven by that particular, thought process. And it's always been one of my contentions, I'm not the only one, who said that one of the problems we have in computing is that it's too easy. In one sense, we can build small systems very quickly, and we can build bigger systems now. We can do things like vibe coding and things like that. But what we forget is that when we want to build something really large and fairly complex, that the difficulty goes up exponentially. And so we have a mindset at the senior level that this is easy, and that if it shouldn't cost. I've never talked to a CEO or CFO who I've talked to in IT projects who's told me, you know what, we've underfunded this and gave more money. Not once in 50 years that I've ever seen somebody in an organization say we have to put more money into our IT project before it starts. Everyone is going to say it shouldn't cost that much. It should cost less. And I always say, well, how many IT projects have you worked on? And it's always none. But I know that it's not that hard. Okay. I don't know how you overcome that. When I was a junior engineer working for the Navy Research Lab up in Newport, Rhode Island, I had a boss. He was one of the early PhDs in computer science, and his name was Tom Conrad. And I talked to Tom, and I was really frustrated one afternoon. We had some requests come down, some requirement that we needed to do to meet in our submarine system, our combat system. We work on moving from analog to digital systems. That's how long I've been working in this field. And it was frustrating because it was stupid. It was the most idiotic requirement, but it was a senior guy who was telling us to do it. And I was asking Tom, when are we ever going to overcome this senioritis problem of them putting requirements down that don't make any technical sense? And he said, when they all retire or die. Well, 50 years later, They've all retired or died, and we're still in the same boat. So this is just embedded. I don't know how we get around this. We need more IT folks, at senior levels. When I wrote the article on software in vehicles, there's 2 articles I wrote for Spectrum on this, which is a follow-up to a story I did back in 2010, I think. People within the industry were saying no senior person who runs a motor vehicle company should not know how to code programs, not just toy programs, but actually be a coder. Because software, they're software-defined vehicles, they're software-driven vehicles, right? High-end vehicles have 300 million lines of code. That is like 5 times more than what's in an F-35 fighter. Okay, so I don't know. We need educated people. That's right. You need to all become CEOs and turn this thing around. Okay, that's the only thing. I can't give you any other advice.
Thank you so much. That was an excellent, insightful answer. We all have to change and turn back to ask questions.
Well, the thing is that if you have a requirements question, if somebody comes in with a new requirements, go back to that same question. What do you know about that requirement, and what should you know about that requirement? And then that gives you also permission to start asking the people above. Well, can you define that a little bit more? What do you want? What do you want? What's your intent? And what's interesting too about just kind of has another thought that came across my mind that what Dennis was talking about earlier was the fact that AI, the problem with AI that we have today, and this is something that Norbert Wiener wrote about back in the 50s, and people now are rediscovering this, is that AI does not understand your context. All right, AI is context free, and this is the real danger that we have. Okay, and that's the issue that the companies, they know it's context free. That's why they have those little things at the bottom that say, we may be wrong, and don't take this seriously, but pay us money because this is really clever. So this whole thing of asking the right questions, asking more questions. One of the things I always did, like when we're working on any system that had multiple interfaces. Oh, okay. I'm motoring on, and I didn't know there was another question.
Hey, Alice, come on.
Hi, sorry, I actually have 2 questions, but sure. I know that somebody else has a question as well, so I'll just ask one of my questions. So one of the things that I had learned in my young professional life was, like, if we could have all the facts, we could design a perfect system that takes every option into account. But military leadership, for example, frequently talks about trying to make the best decision with the information that we have in that moment. And I feel like a lot of leadership and managers ascribe to that mentality. So how do we fix that? We're going to have incomplete information. And then from the leadership perspective, how would a leader balance that with mission scope creep? When it comes to trying to identify what information is actually necessary for this project, and especially because the project might grow, or the context might change, or might get plugged into a system that it was never designed for.
From a designer standpoint, right, one of the things you have to do is build the simplest system possible, right, that you can build on. Because if you try to build anything other than the simplest system that meets the basic requirements, you're going to run into trouble, and you're going to have a mass amount of rework. Senior leadership in the military, part of the problem with the military is that they understand, remember, that they understand that when you're out in combat, I'm a veteran, is that things are very confused. You don't have a lot of information. So they try to bring that mindset over. But part of the problem that they have is that they expect software to be much more robust and system design to be much more robust than it actually is. So there's a disconnect between how they see the world and what they're used to in terms of their environment and what they control, and what happens in software. We saw this all the time in the Navy laboratories, the Army laboratories, which I've worked with, in the Air Force laboratories, is that when you're actually building systems that try to meet a mission need, and there's going to be, say, mission scope, because they always are going to have mission scope. You just have to assume that that's going to be there. That's why you need a simple system that you can continue to add to with those interfaces that are defined, those APIs, is that if you can get them to understand that you can give them what they want, but they have to understand what the limitations of what that software can do and can't do, because they don't understand that at all. I'll give you one really quick story, and then we'll get to another question. Is that when I was in the Navy department, I went to sub school in Groton, Connecticut. I was a combat system designer, so I wanted to see how the training was actually taking place before the crews went out to sea. And so I was in the advanced weapons officer school that I went to, and there was two parts. One had to do with sonar systems, one had to do with combat systems. The sonar people in that training were all concentrated, it was all automated at the time too. They concentrated on how the sonar worked and what you needed to do about the dials and everything, what you were doing. The combat system, they were all worried about how much software was in it, right? They were all proud of you know, the 50 modules they had, the number of lines of code and everything. A totally different mindset, because they did not understand that the software was a tool, and that's because they were impressed with the software itself. Okay, I'm not sure I've answered your question, Alice, but it's a very difficult aspect, building systems in a military environment, mostly because that's not their mindset, and they also, as I said, they assume that this works a lot better than it does.
I think you did answer the question. I think the answer that you said was really a good one. It was like, make it simple and executes well. So that was what I took from it, and I think that probably answers the question.
Well, the military folks, if you ask them, if you go out in the field, right, you go out with a combat unit, you don't want really complicated stuff. You want something that works in the mud, in the rain, in the cold, right? Complicated systems, really hurt you in combat. And so you don't want to do that. So the same thing, that you can use that same time of mindset of saying, do you really want some really complicated piece of equipment that you have to maintain all the time when you're fighting, right? And they're going to say, hell no. So you say, why do you want that with my software, with your software?
Thank you. Can we go to Daniel's question?
Sure.
Daniel?
Yes, am I audible?
Yes.
Excellent. Great presentation, but I have a question on the sort of the grand scheme. I think trying to perfect human beings to fit faulty systems is not really very a useful goal. My thinking would be to assume that human beings are going to be somewhat devious and design the system such that if you are devious, you will be found, and unlike in government, where you're promoted and given raises, you will be punished financially and possibly in prison. And I think that tends to put a real damper on people not telling the truth if they're faced with real consequences. Now they're not. That's why you're getting, you reward bad behavior, you get more. So isn't it better to assume and require open books on any government contracts that are let out, and don't have the government, which is notorious historically for millennia of being corrupt, and put the onus on enterprises that will face severe punishment if they lie?
I think I agree with you to a point, but I'll tell you what, there's a lot of government officials who lie too, right? And so there's lots of managers in government who, to get their programs funded, will lie through their teeth to get that program going. I wrote an article for Spectrum on defense acquisition. And one of the rules of thumb in defense acquisition, if you want your program to get funded, is the promise that you have a capability twice as great as the system you're replacing. If it isn't twice as good, Congress isn't going to fund you. And God knows you don't say you have any risks at all. So the moment you put that in place, guess what? You're going to have a contractor who's going to totally agree, just like IBM totally agreed on instead of walking away from Phoenix, which they should have ethically, they said, "Well, that's what you want. We'll do it." So I agree. I would love in a real environment to have all these contracts, out there in the open with penalties, clauses that are there. But at the same time, I also want requirements that are realistic. I want schedules that are realistic. I want all these things to be realistic. There was an acquisition czar in DoD, his name escapes me for the moment. He put out a project manager's bill of rights, which basically said that if we give you honest estimates of cost and schedule, you will do exactly what you want, Daniel. You'll be accountable for the failures, et cetera, et cetera. Well, no project manager in DoD wanted to sign up for it, and none of the contractors wanted to sign up for it either. So, I agree, humans are going to be devious. The companies are going to lie. There's going to be puffery. But as a good friend of mine said, the contract is the contract. So it's up to the contract to be defined properly. One of the things that used to torque my jaws in government was that we technical people did the proposal reviews. I don't know how many government proposal reviews I did, both while I was in government as well as outside of government. But when it came time for the contract negotiations, guess who was kept away from those contract negotiations?
The people, the reviewers. Yeah.
Right, the technical reviewers. And so what you had is that you had the vendors who were a lot more savvy about what you could and couldn't get away with negotiating the contract. If you wanted to do something to really eliminate a lot of this problem, that would be the first thing I would do, is allow the technical people back in on the contract negotiations. Believe me, I'm a junkyard dog if you put me in a contract negotiation with a vendor.
Well, again, the nexus is government. So the problem is we're letting people in government get away in the positions of power and not holding them accountable.
Yeah,
Maybe, yeah.
I totally agree. I totally agree. There are a lot of people in government, I wanted to see retire early when I was there. Didn't happen, A lot of people in government, I like to retire early now, but can't do that either.
That's excellent. Thank you, Daniel. Are there any other questions? I don't see hands raised.
Well, thank you for your patience. Thank you for asking me some interesting questions. Again, feel free to get in touch with me offline. I'm around, and I'll try to get back to you as soon as I can. And we'll post the video quickly once I get to review it, and the slides will be up along with the reading list and links and things like that. So thank you. I hope you enjoyed it.
This is really great. Thank you so much for all your patience. Like, this is interesting, right? So the time, we didn't even notice the time. Thank you so much for that. We have some quick upcoming invitations to talk about. I'm going to share my screen. Can you all see my screen?
Not yet.
Not
yet. Huh?
Yeah, yeah, now we can see. Yeah.
Thank you.
Yes, we can see.
Thank you. Yeah, that's excellent. So we just finished our question and answers. Thank you so much for all the insightful questions. Thank you once again to Mr. Robert Charette for sharing our expertise and insights with us today. And thank you for all our attendees for joining us and for your thoughtful questions. This is really interesting. Before we wrap up, if you're not yet an IEEE member, and if you find today's session has showed you the value of being part of this community, we highly encourage you to visit ieee.org/join to learn more about the membership benefits and how to get involved. And we also have an announcement. So there is an upcoming meeting that's coming up this Saturday by our new chair, Richmond Section Computer Society chapter, Vigneshwaran, on conversational AI for enterprises. If you haven't registered yet, please do register. So what's next? So we are so excited to continue the speaking series throughout 2026. And we invite you, whether you are an individual attendee or part of the chapters, sections, and affinity groups, to engage with us as attendees, collaborators, or co-host for upcoming sessions. You will also be receiving an anonymous feedback survey link via email. We would greatly appreciate if you could take a couple of minutes to share your thoughts on today's session and suggest topics that you would like to see in the future, or even let us know if you're interested in co-hosting future events. And any suggestions or feedbacks, please do share. We would take it. And finally, we want to have more speakers. So if you or someone you know would make a great speaker for the series, we are actively looking for them. Interested speakers, please reach out to Devendra Rajput or me, Malar Kondappan. So please include a short biography of 3 to 6 sentences about you and a link to your LinkedIn or other professional profile and your proposed speaking topic and abstract, either as a write-up or as a 2-minute video. The selection process is currently being refined, so as soon as it's finalized, we'll share the details and timelines. But please do keep sending your speaking proposals. That will help us to shape the series, identify the tracks, and move the process forward. Thank you again for joining us today. Have a wonderful evening, everyone.
Thank you. Good night.
And thank you all.
Thank you, everyone. Hi, Mr. Allen.
Hello.
Thank you all. Thank you, Malar. Thank you.
Thank you.
So I guess this is goodbye.